Hello everyone. So let's now solve practice assignment week 8 question number 2. Suppose W1 and W2 are subspaces of a vector space V. Let PW1 and PW2 denotes the projection of from V to W1 and V to W2 respectively. Consider the following statement. Find the number of correct statement. So to find the number of correct statement, we will be using this property of projection, that is P square W is equal to taking projection twice, and that would be equal to the same projection mapping. So let's look at first statement P. If PW1 plus PW2 is a projection from V to W1 plus W2, then PW1 composition PW2 plus PW2 composition PW1 is equal to 0. So we have statement 1. So as it is given that PW1 plus PW2 is a projection from V to W1 plus W2. That means this projection mapping should satisfy this condition, as uh, any mapping is only be called as projection if that satisfies this condition. So PW1 plus PW2 composition PW1 plus PW2, and this should be equal to PW1 plus PW2 as it is a projection mapping. Now if we simplify this left side, we will get PW1 composition PW1 plus PW1 composition PW2 plus PW2 composition PW1 plus PW2 composition PW2, and it is equal to PW1 plus PW2. Now here notice this term and the last term. Now in the question it is already given that PW1 denotes the projection from V to W1 and PW2 denotes the projection from V to W2. So that means as these are also the projection mapping, so they will result in PW1 and this would result in PW2, while this middle term will remain as it is. Equal to PW1 plus PW2. Now we can cancel this term here, so we will left with PW1 PW2 plus, that is equal to 0, and that's what it is given here, that if it is a projection from V to W1 plus W2, then PW1 composition PW2 plus PW2 composition PW1 is equal to 0. So statement P is correct. Now let's look at second statement. PW1 square, that is defined like this, PW1 of PW1, so that means taking projection twice, is not a projection from V to W1. Now we know that this is same as from this property, that this would result in PW1 only, and that is already given to us as the projection from V to W1, while option saying it is not a projection from V to W1, so it is wrong. Now third statement, if A is the matrix representation of PW2, then A cannot be the symmetric matrix. Statement 3. So let's consider our V to be R2, W1 to be x-axis, and W2 to be y-axis. So our PW2 is defined from P to W2, that is xy to 0, y, as PW2 is y-axis. So any element from R2 would be just 0, y. It's a simple projection. Now if we take let's say some basis alpha for the domain is 1, 0 and 0, 1, and if we try to find the matrix representation, as we know, then we can see the projection mapping as the linear transformation. So if we want to find the transformation matrix, Okay, let's keep it as pw2 of 1 0. This would be 0 comma 0, and pw2 of 0 comma 1, it would be same as 0 comma 1. Now if we take the same basis for codomain also, then the matrix representation we will get would be 0 0 0 1. And notice that it is a symmetric matrix as the non-diagonal and as these entities are equal, while option says that A cannot be symmetric matrix, so it is wrong. Now last option, Pw1 minus Pw2 is a projection from V to W1 plus W2. So, so again, now consider Pw1 to be V to W1. The W1 and W2 are the same that we considered here, and V is also the same we will consider. So that means this is from x comma y to x comma 0, and Pw2 is V to W2. This is x comma y to 0 comma y. Now option is asking us Pw1 minus Pw2 is a projection from V to W1 plus W2. So now consider the one vector that is 1 comma 1. Now if we do the projection that is Pw1 minus Pw2, so if we first perform Pw1 on the vector 1 comma 1, we'll get 1 comma 0, and on Pw2 we'll get uh, 0 comma 1. Now if we subtract the projection that is Pw1 minus Pw2, we'll get Pw1 is 1 comma 0 and Pw2 is 0 comma 1. So 1 comma 0 minus 0 comma 1, that is 1 comma minus 1. This is the vector that we will get. Now if Pw1 minus Pw2 is a valid projection mapping, then it should satisfy this above condition, that is this here, Pw square. So that means Pw1 minus Pw2 composition, Pw1 minus Pw2, this should be same as Pw1 minus Pw2. And here we got Pw1 minus W2 of 1 comma 1 as 1 comma minus 1. So if we simplify this LHS term now, Pw1 minus Pw2 we got as 1 minus 1. So if we again apply this projection on 1 minus 1, then again first we will do Pw1 on 1 comma minus 1, we'll get 1 comma 0. On Pw2 we get 0 comma minus 1. And what we have to do, we have to subtract these two. So 1 comma 0 minus 0 comma minus 1, so we'll get 1 comma 1. So here this quantity would be this 1 comma 1, and we can see that 1 comma 1 is not equal to 1 comma minus 1. So this is not a projection mapping, hence statement S would be false. Thank you.